Hello, everyone. Today, we're going to be talking about the Symbolic Music project in the Wolfram language. My name is Carlo Giacometti. I am the manager of the Sound and Vision team, and I will be talking to you about Symbolic Music with Rebecca Frederick, who is a developer in the Sound and Vision team. So, in this talk, we will talk about existing capabilities and why we feel like we wanted to introduce some new functionality, what we're planning for import and export, how the primitives and functions related to symbolic music will interact in the Wolfram language, and then a few applications and examples. What are the goals? Why did we decide to do this? Well, we would like to symbolically be able to represent music pieces. Now, you could argue this sound object and, in general, MIDI can do that pretty well. However, that misses a lot of the structure that is kind of inherent to a Western piece of music expressed on a score. For example, there's no concept of measure, there's no concept of time signature, there's no concept of key signature either. So the sound representation that currently already exists in the Wolfram language is very inadequate to represent these concepts from music theory. So what are scores in the wild? Well, some of them are represented in MIDI file. This is a kind of an event-driven representation of music. Something that much more closely follows how a traditional score works is the music XML formats. And this kind of, with a very verbose and complex tree structures, preserves ideas that are very relevant for music theory in general. Another thing we wanted to ensure was that these new primitives should be very good citizens of Wolfram language. So functional programming should work. Anything that you might want to replace or that kind of stuff should work fine with this. We would like to be able to achieve a lot of analysis and a lot of transformations just with existing Wolfram language primitives rather than introducing a gigantic amount of functions. And then obviously we want to enable high-level applications, both in the generations and in the processing and in the analysis departments. So what do we already have in language and in general in the Wolfram ecosystem? Well, one thing that maybe you are aware of, maybe not, is that Wolfram Alpha does have some basic capabilities. For example, this is just a screenshot of if you ask Wolfram Alpha what a Lockeran mode is, you can see it knows notions of scales. It can display some simple scores. Obviously, if you look at this, it doesn't have a time signature. There's a bunch of whole notes that are a very long measure. It can display things. It can give you some information about it. So Wolfram Alpha is already a repository of knowledge about music theory concepts. Now, these do not integrate with any other part of the system, unfortunately, and that's what we're trying to do with this project. The other part is, as I mentioned before, the sound object. So, for example, here I am specifying a bunch of notes. They go into a sound object. This will tell me the pitch. This will tell me the duration. And this makes a noise, which is great. So this is the closest thing that we have to representing a score, but it's not quite there. There is no concept of like the environment these notes live in, right? Is this a measure? How is this duration? How does this duration relate to a tempo of a score? What is the time signature? What is the key signature? All of these things do not exist. This is in some ways kind of similar to MIDI that is very event driven. And for example, this just says play a C note for 1 second. There is no concept of a beat, and the duration of a note as a multiple of some amount of beats. So all of these things do not exist. And all of these concepts have a musical value. So rather than trying to force the existing sound and sound note to carry all of this additional information, we decided that starting with a clean slate would offer us a bit more flexibility and to be able to representing everything a score wants to represent. So let's look at what we're planning for import and export of music. First of all, MIDI is one of the most common formats for this kind of thing. As I said before, it's not like a full score. It doesn't have all of the symbolic structure that a score does have, but it can overlap quite a bit with that. So we are planning to add additional import elements, in this case, a music score and a music voice element that will take a MIDI file and will output some of the new music primitives. I'm taking this as an example of a MIDI file. As you can see, there are 2 voices. It has a time signature, it has a key signature, it gives some information of what the tempo is, and it holds 2 measures. And you can import it as a sound object, but you can also import it as a music score, and you can look at this kind of information. You can look at the voice list, so you can see that there are 2 different voices, each with their own key signature and time signature. And you can see that this is a C# major key signature, and a time signature is a 3/8 time signature. Going slightly deeper into what this new object is, and Rebecca will go in much more detail on how all of these primitives work, but just to give you a glimpse, we want to maintain the structure, right? As I said, score, voices, measures. We have the same thing here. The voice list has inside it a collection of measures, in this case, 2 measures. And each measure has inside it a collection of notes. And you can see notes with pitches, notes with durations. And you can also import a specific music voice rather than the whole thing. A quick caveat, you'll see some odd durations here. MIDI does not quite exactly represent a score either, which is why we get these small discrepancies. In the future, we will want to add export as well to MIDI from music score and music voice objects as well. More plans for the future for the symbolic music framework is to do import and export for the music XML format. As I said, this is a more faithful representation of a musical score. So all of these kind of MIDI-related artifacts will effectively vanish. Another direction that we will want to add is import from PDF and image formats. Oftentimes, these scores could be just a JPEG file on your machine. So this is where musical OCR will play a very important role. 2 more formats that we will look at. We don't have concrete plans on how to import any of these yet, but on our radar are MEI, so XML-based data, and MNX, which is kind of an evolution of the same council that came up with Music XML and all of its versions, is building this other file specification, which is based on JSON rather than XML. So there are already some questions. Symbolic music elements imported from MIDI and Music XML. Well, we don't have a Music XML import quite yet. Um, Stuff is not in the beta of 15 yet, but most of this will be in the release version of Mathematica. We didn't feel we were at a stable enough point to include it in the beta builds yet. One important thing of working with symbolic music is visualization. You've already seen a GUI for music score in the import, but this will this is we're still in kind of the roughing. We still have some rough edges in all this, but the design will be more or less like this. We will have some piano roll display, some meta information at the bottom, and this will be playable like the familiar sound GUI. For music plot, the idea is to have a piano roll representation of the score. So where the x-axis displays the time and the y-axis displays the pitch. And we'll have several options for the x and y-axis. Labeling, in this case, just a simple piano keyboard, but it could as easily be labels that call out pitches at each level. In the future, we will want to display a full score, but typesetting scores is a non-trivial effort that we will not have resources for. But there are some third-party software that we are planning to offload the typesetting to. And we will try to include those pieces of software within our product. But if that doesn't quite work out, I think there will still be the option for the user to install those as backend, and we will be able to make use of them. So I think that is it for import, export, and visualization. And now I will pass the presentation to Rebecca, who will talk about the actual primitives that will be introduced.
Hi, so I'm going to talk about the music framework that we're developing. So we wanted everything to be represented symbolically as an object. So we have a head for a music note, and we have a check for structural validity of all these objects. All of these objects will have their own properties. You can query the properties property to get the list of all of the available ones. You can inspect their values using that subvalue. You can quickly get all of the values for all of their properties using rules. The properties are settable, and other properties should be updated to reflect that change. I'm not sure how much of this is actually in the beta versus the nightly builds, but as an aside, you might see things like absolute properties. What we currently have is that if things are automatic, they're left as automatic, and then there are a set of resolved properties that have actual value, making certain assumptions with default values and such. We also decided that these objects should be entry queue so that you can use the existing functions in the Wolfram language to manipulate them, whether the result is sensible or not. Next slide. What's that? Okay, sorry. So we have a couple types of primitives. The first are event primitives. These are the lower level objects that represent individual events in the score. So the first one, we have a music note, and it has properties such as a duration and beats, a pitch, whether it's tied. So just as a quick example, we've already seen this. Our music note has a pitch, duration, tied before, tied after. An example of some measurements that you might want to compute on a music note is figuring out which scale degree it is in a given scale that would be specified. We also have a way of symbolically representing a musical rest, which just has a duration. So here's a half note rest. we have a way of specifying a where did it go? A chord. That's a very long property list. It's a disclaimer, not all of these will probably end up in the released version. A lot of them are attempts to encapsulate a voicing that isn't the standard inversion. Some of these are note properties. A chord can also have a duration. So as examples, we can create a chord from a list of pitches. We can inspect its interval list. So it can be created from a common name. And we can inspect its list of pitches. The chord doesn't have to be created with an explicit root. So it's displaying its absolute properties. Its pitch list is still automatic. It assumes C for a root, just so that that has a value. But the idea is that a minor chord can be passed around and instantiated with many different roots as needed. Next, we have property primitives. So you might have noticed that the music note, its pitch property was itself a primitive. So we have time signature, and that represents the musical meter. It kind of defines what a beat actually is. And in MIDI, for example, it only knows what quarter notes are. So it has a denominator and a numerator. So for example, we can create a time signature representing 6/8 time, where there are 6 eighth notes to a measure. And the reason that this is useful as it's an object in its own right is that it can be given to containers of musical events to enable it to, say, be partitioned into the correct number of measures, or it can be used to compute a duration of a collection of events in seconds, so that there's a meaning for beats per minute, rather than just assuming that beats per minute is always talking about a quarter note. We have a key signature object, properties such as alteration rules, the accidentals on certain pitches, the fifths away from C, name and a scale. So we can construct a key signature based on the B minor scale, which has 2 sharps. We can query its alteration rules. So for example, these could be used to modify a list of pitches. It's just a list of C, D, E, F, G. We can apply those alteration rules to set the accidentals properly. We have a duration object. So it's also a kind of long list that might become shorter in the future. We have beats with a beats length multiplier, which I'll touch on later. Beats per minute, so that every note can carry its own tempo. That can be used to like map the tempo to implement an accelerando or retardando. Here's a half note as an example. We have a pitch object. So that has properties such as its accidental, its key, that being the white key on a piano, its MIDI number, its sound note number, pitch class integer, an octave. We can create pitches kind of easily from their names. So you can use a scientific pitch notation. You can just pass it a B, a B5. You can give any of these properties as rules. So there's a variety of ways of creating a music note pitch from various numerical indexes. We also have an object for the music interval. So that has a semitones distance, possibly a cent deviation. So here's a music interval with 7 semitones. We also have shortcuts to create these from their common names. The intervals are useful for building up chords. We can nest a bunch of intervals, stack them on top of each other, and get a chord that way. A diminished chord in that case. we can apply arithmetic directly to intervals. So here's an interval of a major second and an interval of a perfect fifth. We can add them to get an interval with 9 semitones, subtract them to get a retrograde fourth. And we can also add and subtract these intervals directly from pitches, music notes, anything that contains a music note, etc. Next, we have container primitives. So the basic one is a music measure that contains music events such as notes, rests, and chords. The measure is the first primitive that can get its own time signature and key signature properties. It has a note list. So here's a measure created from 3 notes. By default, it assumes that the time signature is 3/4 since there's a duration of 3 beats there. If you do specify a time signature, by default, all of these have a duration of 1 beat. It will add a rest if it needs to pad out the measure. And the measures are currently only monophonic unless a chord is present. So here I'm passing it a chord. It's just a shortcut because a chord can be constructed from a list of notes. So here we have a measure list that contains a note, a chord, and another note. Now measures can be combined into a voice. A voice can also have a key signature and a time signature, which can inherit from the measures or conversely propagate down onto the measures. So here we can create a voice from a collection of notes, give it a time signature. It will automatically partition those notes into the correct number of measures and add rests as needed. You can see there are 4 notes, time signatures, and 3/4. So we have 2 measures, and the last one consists of that last note plus a rest. Sometimes a note will need to be broken up if it's going to cross a measure bar. So here we have a C of 1 beat, E 2 beats, G 3 beats, etc. Pass them to a music voice with a time signature of 6/8, and it's going to automatically break those into 3 measures. And we can see that in the second measure, that C has a tied after goes to true property set on it. And there's another C in the last measure. This presentation is acting kind of wonky. So a bunch of voices can be combined into a music score as essentially the same properties, but now it has a voice list instead of a measure list. Carlo already demonstrated the music score GUI, and we can see that there's 1 voice with 1 measure and a bunch of notes. So we also created a couple additional heads just to facilitate generation of these primitives. So for example, a musical scale can be a generator for music note pitches. So here's a music scale based on B minor. It's got a pitch list, an interval list. We can use that pitch list and use those pitches in music notes, etc. A music tuplet will generate a music note duration object with the beat length multiplier properly set. It's a somewhat more intuitive way of entering a triplet. And then we have a music chord progression. This one isn't in the nightly builds yet, but the idea will be to parse this string into a list of musical chords to generate chord objects. So next thing I'm going to talk about, last 4 minutes, is some analysis and processing functions that we have lined up. So rather than introducing a small army of new symbols for all of these tasks, we have two main workhorses. So we have music measurements for computing additional properties and performing various analyses. And that would be, instead of find music X detect, music distance, music chord member queue, music intervals, which would be a terrible name, by the way, music duration. Instead, we can call music measurements on the objects and pass and perform all of those tasks. Or for editing and manipulation, we can use music transformation, and that would take the place of having a bunch of symbols like music part, which again is a terrible name since it part already kind of means the same thing as voice. Music take, split by, extract, music combine, to combine voices into or chords into voices into chords, or music separate to separate chords into voices. Music transpose, that would be an extremely ambiguous name. Okay, so music measurement, that can compute properties and perform various analyses. So here's just a scale, the D harmonic minor scale. Here's a score with notes randomly picked from the scale. That'll just be a small example. So we can query properties on this object. So we can ask for the time signature property. It'll give us a time signature. In contrast, we didn't specify a time signature on this scale, so its property queried directly on the object is still automatic. We can also perform some analysis like the ambitus, which is the minimum and maximum pitch. So apparently this varies from a middle C to the A above it. This random choice of notes. Music transformation, that would be like editing or getting another music object out from a music object that's passed in. So here we have our example again. We can see that its first note is a B flat. We can transpose this entire score up by a perfect fifth, and we can see that now it starts on an F. Can also use music transformations to do things like compute inversions of chords. So here we have a G major. It's going to start on the G. We can ask for a new chord, which is the second inversion of that G major chord, which starts on the fifth. So finally, I'm going to touch on a few applications and examples. We have a minute and a half. I'll have to rush through this. So these functions and primitives could be used to analyze statistics of a piece of music. So you could generate pitch histograms, duration histograms. You could find outlier notes that belong to a different key if you have detected the key of the piece. You could analyze the music as a time series by finding chords. You could try and model a voice using a Markov model. You could identify the key within a music score, label things by their Roman numerals, try and parse out the form from a score, try and identify the rhythm. I mentioned you could do transposition, you could separate chords into voices, combine voices into chords. You can use score calls at exploding and imploding. So obviously you could algorithmically generate like a counterpoint, for example. And one interesting market that we were looking at is the AP music theory classes. Since there's quite a few students enrolled in that, and they have their exams with their written questions. So one thing that they might ask is to transpose a melody. So this would be a good teaching tool or a practice tool to check answers. And that's all I had to share. I hope this was a sufficient overview of the music framework that's in the works right now.
Thank you, Rebecca. I think that was great. I'm going to answer the last few questions that I see in chat. John mentioned that MIDI is successful also for lighting systems. Yep, I am aware, but this doesn't quite fit into a music score or in the symbolic music theory. So we haven't really, we don't really have an application within Mathematica for MIDI in those use cases. Will the new system have more complete knowledge of music theory than Wolfram Alpha? Not much for now, but yes, the goal is to make it better than Wolfram Alpha. And yes, we will add support for augmented 6 curve. That sounds like a great suggestion, George. Thank you. Okay. Any more questions? Oh, I see now in the chat, there is some enthusiasm, which is great to see. Any chance of supporting import from the now defunct Finale? I think Finale will be able to export its files as music XML, if I am not mistaken. I don't think we will be able to import the proprietary Finale files. Well, thank you very much, everyone, for attending and for asking questions. Hopefully, you guys will enjoy this area of functionality once it's released. As I said before, it is still a bit rough around the edges, but we are planning to release this for version 15. Thank you so much, everyone, and have a good day.